Okay, so we've reviewed how we can make alcohols with substitution and addition reactions. We've learned a new way through reduction of aldehydes and ketones. And then in this video, we're going to talk about yet another way to make alcohols, and that's through Grignard reagents. So Grignard reagents are often used in the synthesis of alcohols, and this is another example of an organometallic compound, and we learned a couple of these in 2211, right? And the key to organometallic compounds is that they make carbon nucleophilic, which is relatively rare in organic chemistry. And so to make the Grignard reagent, we just need to react an alkyl halide with magnesium metal. So if we take an alkyl halide, react with magnesium metal, the magnesium essentially inserts itself in between the carbon and the halogen. And so two examples of making Grignard reagents from alkyl halides are given down at the bottom here. Okay, now as I mentioned on the last slide, sort of one of the key features of organometallic compounds is that because the metal is less electronegative than the carbon, it means that the metal is going to be partially positive and the carbon is going to be partially negative. And this is somewhat unusual, right? Because most of the substituents that we add to these organic compounds are things like oxygen and chlorine and nitrogen. All of those elements are more electronegative than carbon, and so it leaves carbon with a partial positive charge. And so one of the unique and useful things about organometallic compounds is that we end up with carbon with a partial negative charge. And so in this case, carbon can act as a nucleophile, and it will also act as a strong base. Okay, so the mechanism by which Grignard reagents react with aldehydes and ketones is very similar to the mechanism of lithium aluminum hydride. So the Grignard reagent reacts as a nucleophile and undergoes nucleophilic attack to the alpha carbon of the aldehyde or the ketone, and then that's followed by a proton transfer step where the now negative oxygen pulls a proton from some proton source, often water, as is shown in this case. Right? Now you might say, why do we need yet another way to make alcohols? We've already learned a bunch of these, right? Well, the key difference is the Grignard reaction gives rise to a new carbon-carbon bond, right? And so this is really important in synthesis. We only had two other ways to make carbon-carbon bonds previously. That was through the Gilman's reagent and through the terminal alkylation, right? And so this gives us yet another way to make new carbon-carbon bonds. And so this will be a very important reaction for us in terms of synthesis, and a very useful reaction in organic chemistry overall. Okay, so just like the reduction reactions we learned in the last video, we can attack the alpha carbon of the carbonyl group from either side. And so in these Grignard reagents, if we form a new chiral center, we'll end up getting a racemic mixture. So we'll get both enantiomers. All right, so not only can Grignard reagents react with aldehydes and ketones, they can also react with esters. Now, the interesting thing in the case of the reaction of the Grignard reagent with an ester is that we're going to add two of the R groups. So in this case, the R group in the Grignard reagent is a methyl, and so we'll convert this ester into an alcohol, but we'll add two of the R groups from the Grignard reagent. Now, the Grignard reagent is both a very good nucleophile, but it's also a very strong base. And you may have noticed in the previous examples, we added the Grignard reagent and the water in two separate steps, and that's really important because the Grignard reagent will react with water or alcohols because of its nature as a very strong base. And so it's really important to keep the Grignard reagents separate from water. And so when you're using these reactions, it's really important to show that we're adding the Grignard reagent and the water in two separate steps. In fact, these compounds are so reactive that they can even react with moisture from the air. And so when we do these reactions, it's really important to keep them away from any moisture. And so the solvents that are used in reactions are very often anhydrous ethers, anything to help keep the water away from the Grignard reagent. All right, so let's finish up this video with an example. And so we want to explain how we would prepare the following compound using a Grignard reaction. And so we're making an alcohol. So I can make this from a Grignard reaction by starting with the Grignard reagent, of course, and then an aldehyde or a ketone. Now, this is the alpha carbon where the Grignard reagent is going to attack, and in addition to the OH, it has 3 other R groups. And so I think we're going to have to start with a ketone. The ketone will provide 2 of the R groups, and then the Grignard reagent will supply the 3rd. But we have choices on how we can go about this. In fact, I think there are 3 different options on how we can go. So we could imagine the ketone providing the phenyl group and the ethyl group, and then the Grignard reagent would provide the methyl group, or any of the other options where, the ketone could provide the phenyl group and the methyl, and the Grignard reagent could provide the ethyl, or the ketone could provide the methyl and the ethyl, and the Grignard reagent would provide the phenyl group. So I think we have 3 possibilities on how we could accomplish forming this compound through a Grignard reaction. So if we draw these 3 out, so if I start, for example, with the ketone containing the phenyl group and the ethyl, then my Grignard reagent needs to provide the methyl group. So I'll have methyl, and then water. Or I could imagine my initial ketone providing the phenyl group and the methyl, in which case my Grignard reagent would need to provide the ethyl group. Or finally, my ketone could provide the ethyl and methyl groups, in which case my Grignard reagent will provide the phenyl group. And so we have 3 different options on how we could achieve formation of this compound through a Grignard reaction.